when we are creating variable, for example, we are allocating the memory, then we are using this in some computations, and we are fetching some data, so it's being used. And we want to, when we don't use it anymore, it should be deallocated in some lower level languages. I remember from university, in C, C++, you have to do it manually. In JavaScript, there is something called garbage collector, which does it automatically for you, or at least it should be, unless you make a memory leak. We have, or I will have several slides of definitions, a couple of visualizations for more difficult definitions, and then we'll jump to Chrome DevTools, and I prepared a couple of examples to make it a bit more interactive. First of all, what is a memory leak? As already in one of the first slides, I could mention that we are allocating some memory for some variable to keep it simple, and it should be released. And when it's not, then when it's no longer needed and it failed to release, then we have a memory leak. In JavaScript, it's exactly the same. When there is a reference to object or variable in memory and we don't use it anymore, then it happens. Under the hood in JavaScript is when the garbage collector cannot reclaim this memory back. There are basically, you can divide this to 3 basic problems. At the beginning, no one would ever notice, because I don't think so most of you have even opened the Chrome DevTools memory tab. Or for example, I have an extension where I can see my memory usage, so no one will even notice. Sometimes with proper monitoring, you might notice a performance degradation, and then you trigger some alerts that okay, there was some memory usage, or mostly it will be about like page loads, all of these Chrome Vital metrics. The problem starts when, of course, application will crash, and then you have to debug it. Thankfully, I never had this pleasure, but I read that this is a disaster to find out what's there. Going further, we will distinguish between 2 definitions, what is stack and what is heap. They are both memory regions for storing data, but they are a bit different. One is more static, one is more dynamic. And we'll start with the simpler one, which is stack. It's a memory region. It stores variables and function calls, and this is actually important that it goes in a sequential order in a so-called LIFO, last in, first out. It's used for storing local variables, function parameters, and return addresses. But you can just remember that, in fact, it will just, to keep it simple, it stores primitives. It's fixed size, but it can also grow and shrink when needed. Heap, again, memory region. It has more dynamic nature. It's used for objects, arrays, and data structures. So let's say the more non-primitives. And it can also grow and shrink. And here we have much more dynamic nature. That's why, even though the memory leaks can occur in both of them, then because of the dynamic nature of heap, it happens over there more often. And in the tools, which I will use a couple of them, and there are not actually that many, so most of them I will show you today, then you will see that it's the tool is measuring the heap. And this is actually from all these slides, if you have, it was just a text, you can basically just remember this image. Stacks is for the primitives, and the heap is for the object data structures. And one more visualization for stack. It's sequential. So for example, if you have like here 4 variables, it will, the first one will be on the bottom, then is the next one name, then is the age, and it's the adult, and then it's leave for last in, first out. So then the adult would go first out by garbage collector. What about the garbage? It's not garbage itself. It's not a memory leak. It's something which is supposed to be collected by garbage collector, or it's like a reference in a memory which is supposed to be collected by garbage collector, and only if or only when the garbage collector is not picking this up, or it's not taking it away, then it becomes a memory leak. There can be also a situation that there is so much garbage in the application that the being produced, so the garbage cannot pick this up, and there is all the time some kind of garbage, and it can be very confusing that this is a memory, but this is just excessive memory consumption, and this can also happen, but this is a little bit in-depth information. What about the garbage collector? It goes into 3 steps. It marks these objects which it can reach. It sweeps away those it cannot. So the algorithm behind garbage collector is called mark and sweep, and then it frees up memory for those it cannot reach. And on one of the blog posts, I find myself it's very straightforward animation how it works. And now we will look on this one more time. So it's marking those objects it can reach, and it's finding them and marking them. Then it will mark those it cannot reach, and it can swap them away and frees up the memory. So maybe it sounds very complicated: memory leaks, memory allocation, garbage collector. But in fact, this is actually most of the work is done for you. But there are a couple of, or actually not only a couple, but it can happen to everybody, that we are making some mistakes. And I will show you a couple of examples right now. We have very good 20 minutes for that. And tools which you can use and see how it is, how it leaks, and how to find out there is a leak and where is it coming from. So first, I have created very dummy memory leak. First, I am just creating some array, and I have a function where I have all my logic. And by the way, everybody here is familiar with JavaScript? Okay, who is not familiar with JavaScript? Raise your hand. Very good. So then I am calling the function with a very pure JavaScript add even listener. I am creating a document fragment, and it's a bit unrealistic example, but it's a very good example for the tooling, which I will show you soon. We are creating 10,000 fragments, appending this to the HTML, and then pushing to the array. Let me open my Visual Studio Code. Okay, so here we are. And I will check. Here I have zoom in, right? Yeah, I think it's better. I have a very clean DOM. Raise to her whoever ever clicked this tab memory. Okay, and who clicked this button? Okay, so we have some specialists. Then we'll take a heap snapshot, because with this button we are making a heap snapshot. Okay, so we have something. I will do a bit like this, so we can see in the heap snapshot we have almost 20 megabytes. I will create 10,000 divs, which you can see it has been created. If you scroll down, then I have 9.5k nodes more. So more or less here will be 500. And in this continuing in the memory tab, I will make a snapshot again. And my heap grew again. Heap, so as I told you, most of the tools are for heap. Because in JavaScript we have stack and heap, but most of the heap where most of the memory leaks occur because due to its dynamic nature. So let me create couple of more times. So we have very nice we can distinguish very nicely again. And we have even more. Okay, so now we have these snapshots. That's the first tool, the first tool you can think of about usage when looking into memory leaks in JavaScript in front-end or in a document object model. And then here I have some complicated stuff. So I can, of course, jump like this, and whoever is very sharp has noticed there is some kind of div which came up. If I look into another one, it's even higher up. We can see times 30,000, times 10,000. But there are also tools like statistics, for example. And I think there is some delay of like 1-2 seconds. Sorry for that. And then we can see a comparison how much of the heap snapshot we have, like in terms of size, and division by the code, strings, JS arrays, type arrays, etc., etc. And of course, I can jump between those two, like this. And again, whoever is very sharp maybe notice that the yellow part grew. So then we are seeing that this is not related to JavaScript, but this is HTML and CSS. So some document object model. If we go even here, then we are seeing that it grew even more. What's interesting, so the statistics is a very nice, very handy tool, easy to understand. We can also do a comparison. So I will compare to my first snapshot, and then I look on size delta, and I can see that the div part grew by 3.6 megabytes. So that's how I can find where is it coming from. And then we have here also one more tab, but here I don't know yet what's going on, so I cannot really explain. And as you can see, I am a bit, I have quite some Chrome extensions here, so this one I will skip. Going next, this is a little bit unrealistic scenario. You will do it that way, of course. Global variables. So I have a global variable, which theoretically I just want to use for survey data. For simplicity, I just created one array with one object. Of course, it should be something like that. So when I call it, let's see what will be there. Of course, you already know what will be there. This I can close. Up. Yeah, so then I am still having my, I'm still having this object even though I don't need it anymore. Of course, we don't want to, I will go through slides. We don't want to, if we don't use it, then we just want to clear it up. So the very first basic outcome is just null your global variables. You can have like a function. I had here a function, but of course you don't need to do it. But maybe I would have much more global variables, so I would just null them out in one function. And let's see what it will be. It will be now. Of course, I have my. So before I null it, of course, there is still an object, but then when I null it, it's null, so it's no longer there. The influence of a global of a single variable on memory is so negligible, so I'm not even going to open the memory tab, and I also want to show different examples. But with global variables, there is one more case when you can make it when you'll make the global variable accidentally without, if you will do it that way, if you will not use let or const or even var, then this then we will still have this variable in the in the memory. Yes. So when here I'm checking this before calling this function. It's a bit. It should be removed. Actually, maybe it's a bit confusing. And then after I call the function, even though I didn't declare a global variable, then I am still having something in my memory because I made it accidentally global variable. So if in my function I will call it and then I will use a let or const, or you can do even var, then it will be no longer there. And I can make it let. And then it's undefined. Yes. Let's look into a bit more realistic example, or more something which is realistic and which we can measure. Document object model nodes, detached ones. When we are creating a variable function, we are calling it, and here we are creating a div. We are appending this to the document body. We are removing this div from the body, so it's no longer in DOM and it's no longer visible for the user, but it will be still in the memory, in fact. And we will see it in a console log again. Before I will remove, I will just show that I have really, so this is my, sorry for the light background. So this is my, this div which I have added, and then I will remove it. It's no longer there anywhere. And let me try just here, make a heap snapshot here. And I will now null it. So the detached node, I will just null it. Maybe I will also show you in the console log. So I am consoling log here after, I will zoom, after I remove it, but it's still it's still here. We can still refer to that. So now I will null it and I will check in console log what happens after. It's null, that's good. And let's see if we are seeing something different here. One moment. Yeah, I'm not going to waste time on debugging. Yeah, that happens when you're doing presentation last time. But in general, when this is the same setup like with global variable, that when you, even though the DOM in the DOM and the UI is gone, then you can also just null it, and then it will be gone. And this is what we think. Closures. So closure, when we have outer function, we are calling it. I will create a large array, and within a function, I return a function which is called closure, and then I return the first element from the array. One moment. This is here. So I will return this one. Yeah, I will make a snapshot. Okay, and now I will create a variable where I will hold just reference to the first element of the array, because that's the only one I want. And now I will do it again. And then we can see a reduction in the heap snapshots. If you are sharp, I have to speed up, then you can see this is the array, right? And it's here, it's not. So now I will compare them, and then I can see in my size delta that the array references no longer in the heap. Because now we are assigning the first element of the array to the variable. So in memory, only this one element needs to be kept. We don't need to keep all of those. How many there are? 1 million? 1 million, all of these elements. It's being garbage collected. And now, my host already showed me I have to speed up. Now there will be no more coding with examples, only slides. Couple of examples, even listeners. You have even listener. You add a listener, and here I just console log. This is also a bit problematic when you want to mitigate up. Make sure to remove even listener. Another quick tip for timers and intervals. When you have the interval and when you call it, then the interval will run all the time until you clear the interval. With set timeout, it will be exactly the same. And I think, so this is for frontend, but in Node.js it's the same. And I guess for other languages, there should be also alternative for timeless intervals. For timeless intervals. Tooling. So we have seen Chrome DevTools. If you have a bit of time, you can, for example, also open, for example, YouTube, but I didn't connect to internet here. Here in a performance tab, make sure to have this memory enabled, or maybe I can play it just very quickly. And then you can also see how this button with collect garbage works. For after 10 seconds, I'll clear something. I will play some different one. And what you will notice here, you will notice the blue line is very interesting for us because this is JS heap, and then you can just try to track it based also on the screenshots you have. Then how it behaves, and also how it behaves after you, for example, here I clear it. After you clear it, for example, for YouTube, very interesting is part when you open this URL. How much is that? Memlab, I don't have that much time actually anymore, but with Memlab, I ran it before this presentation, and this is actually, I think this can be also used in the pipelines because it has lots of CLI options. You'll see like reports based on steps, and you will see lots of interesting data. But what's the most or the easiest to read, you will get the information that if there was a memory leak. Food, I don't know how to pronounce it. In French, it means leak. This is also interesting one, but it runs very long time. You can try to run it at home. I have 2 minutes to go. This one is actually very, very easy. You just need to have the URL. And you can read about alternatives for map and set, called weak map and weak set. I need to slowly finish, but in Chrome Web Tools you have heap snapshot. What we have seen today. You can use the allocation timeline profiler, which I showed you just for a moment in a performance tab, and for detached DOM nodes, I advise to look into Microsoft Edge DevTools because they are better for the last case. MabLab, so this is how we run it. It's a pure puppeteer. You can have a puppeteer script and just execute the memlab on that puppeteer script. The French tool, just run it like this, and you don't need to set up anything. And weak maps and weak sets, they can be helpful to manage memory because they're weaker alternatives for map and set. Basically, unless you explicitly really strongly keep the variable or object in memory, then it will help you to, it will basically help you out a bit. Summary and just our time. Memory leaks are common. Those are the 3 scenarios which mostly you will notice or you can think about when thinking about memory leaks. Can occur both, but look on the heap. Those are the scenarios which can happen, and we have seen today. So be careful on that. The tooling, and important, most of the memory leaks in JavaScript would happen in single-page applications, because on multiple-page application, the page will reload and clean it up by itself. So this is actually, when you will browse YouTube, it will also not preload, or all the other examples I have seen. That's it. I'm perfect on time. If you have, if you want to connect, please scan the QR code. It's my portfolio site. And for questions, if you have questions, let's just have a lunch together. Thank you.